This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. A hypothesis is a statement or claim about the value of a population characteristic or parameter. Hypothesis testing is the statistical method for proving whether the claim or hypothesis is true or otherwise. In general, the way we approach hypothesis testing is by defining the population under study, stating the hypothesis to be investigated, selecting a sample from the population, collecting the data, evaluating the evidence contained in the data, and reaching a conclusion. If we are given a question in relation to hypothesis testing, the population has already been defined. Also, the sample has already been selected from the population and the data collected. So if we are given a hypothesis question, we are really looking at stating the hypothesis to be investigated, evaluating the evidence contained in the data, and reaching a conclusion. The first step we are going to look at is stating the hypothesis to be investigated. In hypothesis testing, we have a null hypothesis, which is denoted H subscript O, and the alternative hypothesis, which is denoted as H subscript 1 or H subscript A. The null hypothesis and the alternative hypothesis are contradictory statements. The null hypothesis is a statement or claim about population parameters which is assumed to be true until it is declared false. It is similar to the idea of innocent until proven guilty. In comparison, the alternative hypothesis is a contradictory hypothesis or statement about the population parameter that will be true if the null hypothesis is false. Another way of thinking about the null hypothesis is that the population characteristic is equal to the hypothesized value. Let's take a look at what the null hypothesis and alternative hypothesis would be for several different questions. The first question states that a survey of 300 randomly selected shoppers showed that the mean spending amount at the weekend is €200 with a sample standard deviation of €20. A department store has claimed that the amount of money spent by shoppers on average at the weekend is €234. We need to state both the null and alternative hypothesis. Previously, we stated that the null hypothesis is the claim or statement that is made and is assumed to be true until proven otherwise. In this case, the department store has claimed that the amount of money spent by shoppers on average at the weekend is €234. Hence, our null hypothesis is the claim that the mean spend is €234. The alternative hypothesis is the contradictory statement. In this case, the mean spend is not €234. The second question states that a company claimed that 75% of their employees travel less than 15 kilometers to work. A sample of 50 employees was randomly selected. The sample found 60% of the employees travel less than 15 kilometers to work. Construct a hypothesis test and clearly state the null hypothesis. In this case, we're still looking at a company claimed, so a statement or a claim that has been made. Once again, our null hypothesis is the claim that has been made, but in this case, rather than it being about the mean, it is being made about the proportion. In this case, our null hypothesis is the proportion of employees who travel less than 15 kilometers to work is 75%. Our alternative hypothesis is the contradictory statement. In this case, our alternative hypothesis is that the proportion of employees who travel less than 15 kilometers to work is not equal to 75%. That concludes the first stage of hypothesis testing. We'll move on to step 2 now. The first step in evaluating the evidence is to identify the level of significance to be used. When we are asked to complete a hypothesis test, it states at a specific level of significance. For the Leaving Certificate, they use a level of 5%. What this means is on a normal distribution, in the two tails, we have 2.5% per tail. These are the extreme values for our normal distribution. These 2.5% on each tail are known as rejection regions. And if our calculated test statistic value, which we will discuss in a few minutes, falls in either of these regions, we reject our null hypothesis. To do this, we need to define our rejection regions, or the Z value associated with our rejection regions. For the Leaving Certificate, we use a 5% level of significance, and this means our Z value associated with the rejection regions is Z equal to plus or minus 1.96. This means that at a 5% significance level, we reject the null hypothesis if our calculated Z is less than minus 1.96 or our calculated Z is greater than 1.96. We will now move on to how we calculate this test statistic Z. What formula we use to calculate the test statistic value depends on what population statistic we are investigating with our hypothesis test. There are two more videos relating to hypothesis testing, one which looks at an example relating to a proportion of population claim, and another video relating to the mean of a population claim. Previously on this video, we looked at a question relating to the mean spend of shoppers. As our hypothesis relates to the mean, we use the z-score formula, z equals x bar minus mu all over the standard deviation divided by the square root of n. For this question, z is equal to x bar, which is 229, minus mu, which is our claimed population mean, 234, divided by the standard deviation, which is 30, divided by the square root of our sample size, in this case 100. And if we do that calculation, we get a value of 1.6667. Therefore, our test statistic calculated is equal to minus 1.67 when rounded. Our last stage is reaching a conclusion. For this, we need to check if our test statistic falls within our rejection regions. Remember, we said that at a 5% significance level, reject the null hypothesis if our Z value is less than minus 1.96 or greater than 1.96. In the previous question, we calculated z-score equal to minus 1.67. This means our z value is greater than minus 1.96 but less than 1.96. Therefore, it does not fall within the rejection region. As our test statistic is not in the rejection region, we fail to reject the null hypothesis. This phrasing is very important. It is important to say we fail to reject the null hypothesis. In comparison, if our test value had fallen in the rejection region, we would have rejected the null hypothesis. To finally conclude the hypothesis test, we must state the conclusion in the context of the problem. By this I mean we go back to our null or alternative hypothesis and restate what our findings suggest. For example, in context of the previous question, we failed to reject a null hypothesis. So in that case, we might conclude that the mean amount spent by shoppers at the weekend was €234. That concludes the video on hypothesis testing. There are 2 more videos relating to hypothesis testing examples.